Hello everybody, welcome to another video of me trying to learn systems programming by learning the Zig programming language. For those of you who have been following me for the last couple of videos, I've been following this Ziglinks course, which is a bunch of fun little exercises by Chris Bosch. And the idea is by solving these fun little programs, fixing them, and completing the questions, we will eventually get a foundational understanding of Zig, and that'll help us to go on a trajectory where we can learn systems programming, understand the software hardware interfaces, and so on. Without wasting much time, let's jump in to the next exercise. So previously, if you remember, we looked at functions. We also did a fun little quiz. We understood how functions work, their use case. Then we also did a little bit of errors, looked at a little bit of errors in Zig, and how they're a value type and why that's important, how it changes the way we think, but it also makes it quite straightforward in terms of managing whether the output of a function would be either an actual value or potentially an error. And we saw this fun little syntax where we can either write our error type that we've defined with the different error values, or we can say that, oh, this particular thing is the actual value that's going to be assigned to a variable. So yeah, I thought that was pretty fun. In that spirit, let's continue learning about some more errors. Cool. One way to deal with error unions is to catch any error and replace it with a default value. Okay, so that's foo here, can fail, and catch 6. So I believe this is trying to say can fail, which means if this ever throws an error, we will instead assign foo to 6. So this is almost a shorthand try-catch block, which is common in other languages. Let's see. Pretty straightforward, standard function imported. We have the error union here, and these are the different legal values of that union. We're calling it the my number error type. Okay, we have the public main function. We have two unsigned integers here, and we're calling a function, and we're saying if it throws an error, catch it and instead throw 22. I'm assuming this is going to be quite the same. We're calling the same function. If an error occurs, we'll catch and throw 22. Cool. Now, please provide the return type from this function. Looking at it, the return type can either be this error value of the error value, where I believe is this called a union? I believe so. It's an error type, and it can be too small or it can be a valid number. Let's see. Cool. We have a valid number here. So I'm going to say this can either be a my number error, or it can be an unsigned integer of 32 bits. I believe that solves the issue. Let me clear the screen and we'll run Zig run 023 errors. Perfect, we have it working. We see that for the second one, we had an error. For the first one, we actually got the value, which makes sense if the number is less than 5. In the second example, in the second call, it's 4, 4 is less than 5, so we're throwing an error. The error is caught, and instead 22 is returned. Pretty straightforward, and just for my own recollection, and if somebody is again looking at this for the first time from another language, or if they've never done another language, a quick little introduction to what sort of a try-catch block looks like in most other languages. Essentially, you will have try, and here's some instructions that may or may not fail. Here you'll have a catch generally, and this is again from an example from an object-oriented language, but generally you will have an exception class here, and let's say we can call this EX, do something with the exception. Generally it is related to logging. For example, in C#, it's quite common an exception occurs. Usually it's automatically logged as well, especially with the modern open telemetry distro, and adding in the service defaults that are actually rated by Microsoft as well. And some of the defaults are really great if you're using something like an Aspire structure or an Aspire app. But essentially you would do some logging here, writing it to some sort of a sync, which could be application insights, log analytics, workspaces, could be anything. And the other thing you'll have is a finally block, and here is where you would do free up resources that were allocated. Usually in web servers, at least in some framework like ASP.NET Core, your request and operations are scoped to the request. So when the request fails, most resources are freed up by default. But there are some instances where finally that makes a lot of sense, especially in background services and things like that. You've got to keep an eye out on finally. Essentially this seems like a shorthand version of that, where if an error occurs, catch and return 22. That provides a little bit of context to myself to recollect, as well as for anybody else. And on the rare chance that somebody else is watching this, maybe it helps them out too. Cool. Let me leave this for now. It's okay. Let's move on to the next problem. I'm going to clear this. Cool. Using catch to replace an error with a default value is a bit of a blunt instrument, since it doesn't matter what the error is. Interesting. That is something I actually didn't pay attention to. I thought about it for a second, but I just forgot in the flow. Yep, that is right. If you look at this, here we can have multiple catch blocks. Again, this is not Zig, but I'm just saying. So it could be argument null exception, or it could be whatever, divide by 0, or some custom exception. And there is a chance that certain exceptions need to be handled differently. For example, even if you look at logging, for certain exceptions that could be assuming we're not talking about resilience pipelines and any of those things for now, say a transient error occurs. The way we would handle that, or the way we would log that, sometimes would be very different from, say, a user error occurs. The user, for whatever reason, input an illegal value, or they're trying to, or our front-end validation is not good, but the back-end database inserts are failing. So different exceptions need to be handled differently, and one of the ways is that you identify the kind of exception that has occurred, and then you will have the handling code in a catch block. Again, in Zig, we have errors, and we're not really talking about exceptions, we're talking about errors as a value type. But again, we do want to have, since we saw that the errors union, we could create different categories or types of errors. We do want a more precise way of handling it. So I believe that's what this particular example will say. So catch lets us capture the error value and perform additional actions in this form. That's right, in this more expressive or verbose form, we can do a lot more useful thing right off the bat. Very similar to the for each syntax. In for each would have for each the collection and the brackets, and then you have this. I do not know exactly what this character is called. I've used it quite a bit. Even when you're writing logical or operators, we use it. Straight line. I don't know. I'm sure it has a fancy name. But essentially, this makes sense. So when an error occurs, you catch it. In this case, you expressively say, there's a type error. Now this particular ERR error is a placeholder that can hold one of the possible errors generated from this union, from this one of the errors that is potentially generated, and that error conforms to one particular union of errors, like say fish errors, and now we can go and compare it. Cool. I wonder if it can throw different. I wonder if we can chain errors. Let me just try it. I know we want to trust the process and not take too much time, but I wonder if we can have our own errors defined, like my test error, and we'll say some error. We're just doing this to test a theory of mine. Can we chain this and say, okay, we can. Great. That's how the real world operates. We can't always treat everything like a homogeneous collection, like an array. Let's see. My test error dot some error, and we'll say else if n is equal to 99, we'll return some error. And let me add another value here, ABC 99, and we want to catch and say some double quotes. This is in JavaScript. This is in the wild west of JavaScript. Occurred, and we will change this into string. So I'll say infer it yourself. Right. Actually, let me just try it. It's either going to be this or U8. Would that work? I guess you can't infer it. But isn't this how we would define strings? Unable to infer the array size. I see. 4, 5, 6, 7, 8, 9, 10, 11. How many characters is here? 1, 2, 3, 11, 12, 13, 14, 16, I guess. Unused constant. This becomes interesting. Now, how do we display C? If it's a string, we need to show integer to string conversion should be fairly straightforward. And I don't think there's a loss of precision, so I'm just going to go and assume it'll work. But let's see. Curious. So, too excited there, forgot the run command. Failed here. It's not a member of destination error set. Add 20. My number error, my test error. Function return type. Some error is not a member of destination error set. Wait. some error. Error dot some error is not a member of the destination error set. Oh, but it's working here. 0 to 3, it should either be error too small, error of some error, or you found error of some error. But we are saying, I thought we're doing the same thing. So we can't chain it in Zig? Not U29, U25. Error dot some error is not a member of the destination error set. Let me try and understand it. It is a member unless it's treating this. Oh, is it treating it like that? Five, 27, 25, 23. Function return type declared here. Yeah, I'm still curious. Let me switch over to the browser. Let's look at something. Let's look at documentations. Let's look at errors, set type. Let's look at an example of a function. Everything has exactly one allocation error. Okay, there's only one type of error. I see what's happening here. What I'm going to try is I'm going to try some funky regex. Merging error sets. Oh, I see here. Needs to be merged before we use it. Okay. Possible errors. My number error or my test error. Does this fix? Okay, that actually fixed it. Okay, perfect. Documentation was really good. We found it pretty quick. I know we're going on a tangent here. I'm just curious. I do trust the process, and I know I shouldn't jump left, right, and center, but it's just very interesting of a topic. Okay, expected set type, but found U32. Huh, that's right. Why would it ever be U32? My bad. Let's clear that up. Oh, that's right. That's right, because it can either be U32 or a set. I'm just curious. How in this case the function can return one of these values. So I'm trying to say it can either be, but this is potentially only meant for errors, I think. Um, I'm sure there's a way for this variable to either be one value or the other. Uh, Too much JavaScriptiness and dynamic typing here. Wonder if the compiler is looking at me and like, you do not deserve to learn Zig. Okay, for the time being, I'm not going to push boundaries. I'm going to say 1. Oh, my bad, sorry. Got to treat this too. Very nice, the compiler telling us, hey, what are you trying to do? Converting and I'm trying to DJ 32-bit to string. Oh, okay, so it's not going to promote the type. Good to know. Good to know. Type of, and it's even telling me how I can do this. Yeah, okay, that's good to know. Less magic under the hood, more precise are requirements to write code, and it means very deterministic outputs. Completely fair of a game. Perfect. Now we have C working, and now we even built a fun little what do we call this? What is this thing called? Is it a union? A merged error set. I saw the word union used somewhere here. Was it in this example? Error unions, but I saw the documentation said error sets. Okay, let me just try to understand that. An error set type and normal type can be combined. That forms an error union type. I see. That's what it's called when we combine a normal type and an error type. It's called an error union type. Makes sense. Oh yeah, I remember this now. I remember from looking at this previously. I'm certain. Where was it? It was exercise 3. Error unions. Exactly. Error union is, we have the error type with a normal type. Perfect. Good. I'm glad I took that slight detour. Oh, my bad. I realized I might not have shared the code at all. All good though. Let me quickly go over it. Cool. Essentially, what I did was I was trying to make this fun little syntax, but I wanted to see if I can have 2 error sets. Have a way where we can return one of the 2 error sets. And the way, when I looked at the documentation, I realized that, oh, we can do it by doing an OR operations in the first 2 sets. That's getting assigned to possible errors, and then we can return the possible errors here. The program worked, if anybody's curious. My bad, I forgot to share the code. Fun little exercise, made a lot of sense. I need to watch and make sure I'm sharing the right screen. Cool. Without much ado, let's get back into the next example. Using catch to replace an error with a default value is a bit of a blunt instrument since it doesn't matter what the error is. Okay. Yes, we understood that. We already went through that. Makes sense. We're using the ERR syntax. And we're comparing the actual error to see whether it's part of that error set or part of that value in the error set. Nice. So we have the constant, we have the standard function, we have our error set, we have too small, too big as the values, and we have our function. The catch 0 below is a temporary hack to deal with make just rights returned error union for now. Okay. they're trying to say, fine, since this can either return the error or the union, for now we're just going to go and say we have these placeholder values. That's fine, understandable. In this silly example, we've split the responsibility of making a number just right into 4 functions. So make just right, fix too big, fix too small, detect problems. Okay, make just right calls fix too big, cannot fix any errors. Calls fix too small, fix too big errors. Calls detect problem, fixes too small errors. Okay, returns the number or an error. It's funny that this is a silly and possibly not the most tasteful way to write code, but it is sometimes when we're building large applications, different people write different functions, and then they write an abstraction over that function, an abstraction over that. So it is quite the common thing that happens in enterprise code bases, and we want to avoid that as much as we can. But in this case, this silly problem feels like home. Cool. Now let's go to a make just right function. So obviously we have the error union here with unsigned integers. So this calls the fix too big function now, which seems to be returning the error with an unsigned integer again, accepts an unsigned integer, and which now calls the fix too small function, which is defined here, and it has the errors that it can return, and if it's too big, it'll max it out at 20. Fix too small. Oh dear, this function is missing a lot, but don't worry, it's nearly identical for fix too above. If we get too small error, we should return 10. If we get any other error, we should return that error. Otherwise, we return the U32 number. Okay, so we're calling the detect problem function, and we're going to use the more verbose catch syntax, and we're going to say, so U32 can return either my error or my number error unsigned integer. So we'll say it's ERR. We'll open the catch block. So the scope begins similar to here. And now we're going to obviously write the if statement, and we're going to say, hey, ERR, if you are type my number error dot too small, we're going to return 10, because if you're too small, we'll set the min ceiling to 10. Else we'll just return whatever ERR is, right? Is that what we're expecting? But what if it's a valid value? We don't want to swallow it here, which is what we're doing. If we get any other error, we should return that error. I see. Okay. Otherwise we return the, so what'll be here? Okay, that's right. Only if the error occurs, it'll run here. If the error does not occur, this would automatically return. Makes sense. Let's run this code. Oh, my bad. What did I do here? Error set is ignored. Let's see. Let's compare to what we already have. Error double equals 9 my number dot too small. Okay. Oh, I see. We can do else return error. Was that the error I was trying to tell me about? Yeah, that's what I was trying to tell. Yes, that makes perfect sense. It's like, hey buddy, what are you trying to do here? You're saying you're giving a proper if conditional, but else does not return. So the catch block is like, yeah, I see what it's trying to say. In which case, when we hit the catch block, nothing is being returned, and it's like it does not conform. Good. It's a good compiler error we ran into. Makes sense. I think I get a good understanding of errors work. Something else that I want to note here that just flashed was how errors is a value type. I think we explored this in the previous video, but now I'm again, these videos are not pure courses from somebody who knows Zig. The video series is essentially me figuring Zig out. So after Zig links, we'll go and start reading the documentation, which is the next set of videos that I've planned in our journey to learn Zig. And by extension, the true goal is not just to learn Zig for Zig's sake, although it's not a bad thing. My personal true goal is to learn systems programming, and Zig is just a vessel for me to do that. So one of the things that I noticed is errors here. What it means when we say a value type. The flow of control in the program is never interrupted here. Like, say this was an exception in another language. We're not trying to return anything at that point. Literally, something is caught, and now we're essentially at the mercy of stack traces, and we can't really return from it because the flow of control is essentially broken. And if you do want to return, it's a whole bunch of nested try catches, and we're swallowing stack traces. But in Zig, it is very different. It's a different way of thinking. Something that I've been sort of used to from because I tried learning a bit of Go, and I think I've sort of transitioned into this way of thinking. But regardless, it's the value error as a value. Very interesting. It makes sense to me. The more I read it, those simple English words make more and more sense, and the context of how Zig is the way it is. Perfect. On that note, let's move on to the next exercise. Cool. Zig is a handy try shortcut for this common error handling pattern. So we have can fail, catch, error, return error, which can be compactly written as try, can fail. Okay, I understand this. Try in Zig. I remember seeing this somewhere. Maybe when I first downloaded Zig and I was trying to see the first how a simple program looks. I remember seeing try when it was trying to write something to the standard output, I feel. And I wondered what it was. I was like, oh, yeah, I thought it swallows errors or something like that. This makes a lot of sense. It's a shorthand. In previous example, we were doing catch fail, can fail, and catch throw a default value. In this case, we're saying, hey, we want you to write this, call this whatever function per piece of code. If an error occurs, catch, assign it to a type, assign it to the variable ERR or constant ERR, and then just return it. And instead of being verbose like this, we have a shorthand. And shorthands are good. Sensible shorthands are good because reducing the size of the code is really, really important over time. Because even when we come back and we read it, if it's hard to read, we will not really understand it. There's been so many instances where I've written a piece of code and 6 to 12 months go by, and you come back and see this, I'm like, who wrote this? And you look at the Git history and it's your name on it. So it is very important to keep things minimalist, but not overly minimalist and not overly expressive either. In this case, try is a sensible shorthand. Makes sense. Perfect. Now we have the standard library which we've imported. We have the error type here, the constant error type, and we have these two possible values in this error set. Perfect. Now, good. I believe these are placeholder values that they've added zeros for now. Either we're going to get the actual value or we're going to get a 0. Okay. Now we have the add5 function which is being called, and say this function needs to return any error which might come back from detect. Please use a try statement rather than a catch statement. Okay, makes sense. Before I do that, since right off the bat in VS Code I see there's no red squiggly, which means there's no straight up syntax errors. Whenever there's no blatant syntax errors, I do want to run the program directly. This is to see what we're going to get as errors. Okay, first error, we have line 31 versus x plus 5. X, unfortunately, can either be unsigned integer or an error, and types are compile time primitives, right? It's saying, hey buddy, there's two possible values of x, and one of those possible values cannot be used with the plus operator because there's no overload for it. So what you're doing is unfortunately illegal based on the language semantics. Okay, now how do we solve this? The answer is right here. Let's do it the more expressive way first, and then we'll come back to try. So the first way, we'll do ERR, and we'll say if one of two errors, right? So we'll say if ERR is equal to my number error dot too small, or we'll say if ERR is equal to my number error dot too big. Okay, what's the error here? Comparison operators cannot be changed. Oh, okay. What if I did this? That help? Because now we have the operator precedence being solved here, and we don't have to worry about the precedence of the operators. Let's see, let's go on. I know we didn't see an example like this. It's just almost a force of habit, to be honest. And we'll say if an error has occurred, we will return the error as it is, or else we will return nothing else, right? Wonder how the compiler will treat this, because ideally we would just want to write this, but if I write it like this, will the compilers look at it and say any possible value of this set, all of them are being checked, so there is no problem here? Or is it going to say, what are you trying to do here? Okay, there is an error, unable to evaluate comp time expression. Operation is runtime due to this operand. Error is being compared against two different things. I want to understand, how is this different than what we were doing before? Right? How is it different than this? Is it my use of parentheses? Was that not a solution to the Zig's complaint? and more and more of a workaround that I attempted to do? That's good. It's good. We do want to trust the process and follow along the exercises, but sometimes it's just can't help yourself. You just want to dig deeper right then and there because the topic is so fascinating. Let's see what the compiler is going to say for this one. Okay, it's incompatible types, U32 and void. I just want to write this too. I want to know what happens now. Okay, it was something that I was just trying to test, and I kind of knew that it doesn't make sense. I was trying to see, essentially, here's what I was trying to explore. I was trying to see, what if I individually check them, and would the Zig compiler look at this and say, hey, he's checking against every possible value within the error set that can be returned, and is it safe now? But Zig is saying, okay, you are logically doing the right thing. However, just by the semantics, the way you've written it, I will not assume that what you have written is right, because for if and if there is a return, but what if it enters, the flow of control enters here? Will it happen? No. I know that by looking at it, but the compiler is saying, I think it's saying, no, doesn't make sense. There needs to be something returned here expressively, otherwise the function type, the return can be a void, right? Is that what it's trying to say here? Line 29. Yup, it's saying there's a possibility there's going to be a void. But the second we write this, it negates the need for this anyway, even if it runs. And we know this is going to work. So what's it doing here? Whenever it's 4 will cause the error, right? Less than 10, too small. Greater than 20, too small. Yeah. These are, the first one would be too big. This would be too small, and this would work because it's within the 10 to 20 range. Regardless, now let's write the shorthand for this. Okay, yep. So it's looking at my number error. It's calling the detection function. It's looking that an error occurred. So the second an error occurred, immediately a return happens. And this isn't like like C#, where suppose we were throwing an exception, not an error, an exception. It immediately throws it by itself, and it's going back to the caller and for a try block that can handle it. In this case, this is essentially almost like generating that return for us. It's just a shorthand for it. Since it's already going to get returned here when an error occurs, this would never run. Since this would never run, we would never have an error. Yep. Understood. Makes sense. I think that was a good example. Let's see what the next example is. Okay, actually let me pause here. I think we got a good grasp of things. We tried a couple of things, and I do want to keep the video under 30 minutes. Again, the idea is we write something, we think about it a little bit, we come back tomorrow or whenever we try and learn again and recollect a little bit more. We want bite-sized chunks. The goal isn't to go from beginner in Zig to beginner plus within 10 days or 5 days or 30 days. The goal, at least that I've set for myself, is I want to understand Zig slowly and gradually and ramp up. So once all the exercises are done, we go back, read the documentation again, and then maybe go on Exercism or one of those sites and practice utilizing Zig to solve simple coding problems. And the idea is to master, or what would be a better term, uh, to sort of have a deep technical understanding of the language, what the language is truly about, and appreciate how that ties into systems programming. And I can right off the bat, the treatment of errors as a value type. I think that itself, I don't think I truly grasp it. I think I got the idea a little bit in the previous video, but in this video I'm like, okay, there's more to it. Even though it's simple, that simple is also very powerful. So yeah, I think it's a good point to end the video. It's been great. Let me go back to the browser. I know briefly in one of my asides, I didn't have the code showing, and I was rambling through it, and all you guys were seeing was the browser. But besides the point, I think the exercises from Chris Bosch, and we have some other contributors here as well. But I am really happy that somebody took the time to build all of this together. So do go to the repository if Zig is something you want to learn, and I would recommend giving this person a star, just to show appreciation and say, hey, thank you for your time and effort. And again, if you want to learn Zig, the documentation here too, I refer to it from time to time, but this is something I want to do in the next series as well, once we go through the exercises, which there's plenty of time for that. And I also, I think I saw in an interview quite recently that 0.17 is right around the corner. Excited for that. Anyway, we'll end the video here. It's been great fun learning Zig. I know the video is not the most organized. There's a bit of asides with each exercises, but I hope we're all sort of learning the language, getting better at thinking about writing software with the hardware, and with the approach of truly utilizing the hardware's capabilities. Anyway, it's been fun. I'll stop rambling. See you all in another video. Bye.